In this video, we will explore the concept of a process in operating systems. We'll define what a process is, examine its key properties, and discuss the different states a process can be in during its life cycle. Let's dive in. So, what exactly is a process? A process is essentially a program that is in execution. It is the fundamental unit of work in an operating system. Think of it as an instance of a program that's currently running on your computer. When you double-click an icon to open an application, you're starting a process. Now let's discuss the key properties of a process. First is the program counter. The program counter keeps track of the next instruction that will be executed for that particular process. The next property is the process state. The process state represents the current condition of a process. It can be in one of several states such as new, ready, running, waiting, or terminated. The third property is the process ID, also known as PID. The process ID is a unique identifier that the operating system assigns to each process. This ID helps the OS to keep track of and manage individual processes. The final property is memory. Each process has its own memory space. This memory space includes areas for the code, data, stack, and heap. Let's explore even more process properties. First are the CPU registers. CPU registers are used to store register values when the process is not running. This allows the execution to resume correctly when the process is scheduled to run again. The second property is the input-output status. Input-output status includes information about allocated input and output devices and any open files associated with the process. The third property is the CPU scheduling information. CPU scheduling information includes parameters like priority, scheduling queue pointers, and other data needed for scheduling. The final property is the accounting information. Accounting information includes the CPU time used, time limits, account numbers, and other resource usage statistics. Let's talk about the process control block, also known as the PCB. The process control block is a data structure that contains all the information about a process. It is the repository for any information that may vary from process to process. The PCB is created when a process is created and is deleted when the process terminates. As a process executes, it changes state according to its current activity. This state transitions are essential for how the operating system manages the execution of processes. Let's discuss the process states in more detail. First, we have the new state. This is where the process is being created. During this state, memory is allocated for the process and the process control block is initialized. But the process is not yet admitted to the pool of executable processes. Moving on, we have the ready state. In the ready state, the process is waiting to be assigned to a processor. The process has all the resources needed to run, except for the CPU itself. There could be multiple processes in the ready state forming a ready queue. Processes remain in the ready state until the scheduler selects them for execution. Next is the running state. In the running state, the process is actively executing on a CPU. Instructions are being executed by the processor. Note that only one process per CPU can be in the running state at any given time. A process can leave the running state due to interrupts, input and output requests, or completion. Next, we have the waiting state. In the waiting state, the process is waiting for some event to occur, such as input and output completion, resource availability, or waiting for a signal. The process cannot execute until the event it's waiting for occurs. There may be multiple waiting queues for different types of events. Finally, we have the terminated state. In the terminated state, the process has finished execution. The process may terminate voluntarily upon completion, or it may be terminated by the operating system. The resources that were allocated to the process are deallocated and reclaimed by the operating system. The PCB may be maintained temporarily for accounting and debugging purposes. To summarize, a process is a program in execution. Each process has its own process control block, which contains all the information about the process. Processes go through different states, including new, ready, running, waiting, and terminated. And finally, the operating system manages processes through scheduling and context switching. Process management is a fundamental responsibility of the operating system. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.